Hi Year 13s, I'm going to do a tricky exam question using the binomial expansion. Okay, I'm going to ignore the first part, the show that part. We can see that we're expanding x over 1 minus x cubed. So that could be written as x times 1 minus x to the negative 3, and then you just use your binomial expansion formula and multiply everything by x at the end. And so we should get x plus 3x squared plus 6x cubed for small values of x. So we're going to use this result, okay, together with a suitable value of x to find a decimal estimate of 100 over 729. Okay, so if we're looking here, it's this 729 is going to kind of give us the clue. So we've got 1 minus x cubed should be something to do with 729. Okay, so if you cube root 729, that would suggest that you've got 9. So 1 minus x is equal to 9. Okay. So that's not really going to work, but we can look for something that is related but is less than 1. So if we use x is 0.1, then 1 minus 0.1 is equal to 0.9. Okay, and let's see if that's going to work with the rest of the fraction. Okay, so x over 1 minus x cubed, okay, is equal to our x plus 3x squared plus 6x cubed. If we put 0.1 in there, over 1 minus 0.1 all cubed, that gives us 0.1 plus 3 times 0.01 plus 6 times 0.001. Okay, now let's tidy this up so it looks a lot nicer. Alright, so this will give us 0.1 over 0.9 cubed, and on this side we've got 0.136. Okay, if we want to, well, we're going to cube that number at the bottom, so we've got 0.1 over 0.9 cubes, which is 0.729. So that's looking more hopeful, isn't it? That's more like our 729. And in order to not have decimals within our fraction, okay, then we're going to multiply top and bottom by 100, and we indeed end up with the exact fraction that we want. Okay, so the next part of this question is manipulating some algebra. All right, so I'm going to just move this out of the way so we can see. So we're looking at part 3. Okay, we've got to show that x over 1 minus x all cubed is equal to minus 1 over x squared times 1 minus 1 over x to the minus 3. So the first thing I'm going to do is look for any kind of hooks that are going to connect the two. So we've got our bracket to the minus 3, we've got our bracket cubed, which is the same as like times the bracket to the minus 3. So somehow we've got to get from x to 1 over x. So I'm going to start with this one here. So we've got x over 1 minus x cubed. And I'm kind of going to use our trick for when we don't have a 1 at the start. So we take out a factor. So I'm going to take out the factor of x. Now that will leave me with 1 over x take away 1, which at least is looking a bit better, isn't it? A bit more like it. The only problem is this is kind of the opposite signs. So instead of having x outside, I'm going to decide to have minus x. Okay, and so then I will have 1 minus 1 over x. Oops, all cubed. So now we're going to raise each part to the power of 3. So we've got x over minus x cubed is going to be minus x cubed. Okay, and then we've got 1 minus 1 over x cubed. Okay, and then all we have to do is write it in the format that we've got. So we've got x over minus x cubed, so that is 1 over minus 1 over x squared, and then 1 1 over 1 minus 1 over x cubed is 1 minus 1 over x to the negative 3. Okay, so that was the third part, and it's worked. Right. The very last part is comment on the suitability of using the same value of x as we used in part 2. So in part 2 we used x was 0.1. Okay, oops, there we go. In the expansion, okay, to estimate 100 over 729. Okay, well the expandy bit is the 1 minus 1 over x to the negative 3. And the range of validity would be 1 over x. The modulus of that is less than 1. Okay, so that would then have us as having, if we just look at 1 over x. Okay, if we want 1 over x is less than 1, all right, then we're going to be looking at x has got to be greater than 1, or indeed we could also have x is less than negative 1. Now 0.1 is not greater than 1 or less than negative 1. So 0.1 is not in the range of values for which the expansion is valid. So it will be an unsuitable value for estimation. Okay.